How do we solve this question? Find the real numbers x and y if this whole complicated expression is the conjugate of this complex number. Okay, that's what the question says. So let's take a look at this question. And real numbers x and y are real numbers, and this is the conjugate of this. Okay, so let z equals minus 6 minus 24i. Okay, this is a complex number given, and this whole thing is a conjugate of this, therefore, and z bar is equal to, since conjugate of this is this, x minus iy times 3 plus 5i. This is given to me, right? This is given to me, yes. Z bar equals to this. This is also given. This is also given. Right. So therefore, I can say that Z bar, for this Z bar can easily be found as minus 4 minus 6 plus 24i. This is the actual conjugate of this, which I can directly see from here. And this is equal to this x minus iy times 3 plus 5i. I hope that's okay. Yes, that's pretty simple. And on rearranging this expression, what I get is x minus iy will be actually equal to what? Divide with 3 plus 5i. Minus 6 plus 24i over 3 plus 5i. This is equal to this. Now that complex number over here on the LHS has real term, real part x, and the imaginary part minus y, and on simplifying this in the form a plus ib, will get the values of x and y very easily. So the next task that we are supposed to follow is simplifying this expression. And how do we do that? We'll have to multiply with the complex conjugate of denominator 3 minus 5i in the numerator and in the denominator as well. Let's multiply this. Therefore, x minus iy becomes equal to what? These two terms will get multiplied. Let's apply the distributive law. This minus 6 gets multiplied by 3, which gives me minus 18. Minus 6 gets multiplied with minus 5i, which gives me plus 30i. Okay. 24i gets multiplied with 3, which gives me 72i. And 24i gets multiplied with minus 5i, which gives me minus 120i square. And what about the denominator? In the denominator, you have a plus b and a minus b, which will be a square minus b square, which is 25i ka whole square. What next? This is minus 120i square, minus 120i square. I square is minus 1. That will give us plus 120 over here. Plus 120 minus 18 is plus 102. That's what I get, right? Plus 102. What about the second term? This is 72 plus 30, which is plus 102i in the numerator, as you can observe, right? What about the denominator? In the denominator, you have 25i square. I square is minus 1. This becomes plus 25. Plus 25 plus 9 is 34 actually. 34 in the denominator. Can you observe that? Yes. This is 34 in the denominator. And on observing this, what next? 34 times 3. This is 3 plus 3i over here. Right? This is 3 plus 3i over here. And yes, this is equal to x minus iy. On comparison of the real parts, we get x equals 3 and minus y equals 3, which gives me y equals minus 3. So x is simply equal to 3 and y is equal to minus 3. This is obtained by comparing the real parts, and this is obtained by comparing the imaginary parts of LHS and RHS, since the two complex numbers are equal. And yes, that is all for this question over here, as you can see completely, right?